Hello, class. Mr. Bean here for AP Physics. This is video 12. We're talking a little bit about gravitation and see what all that's about. Anyway, let's go ahead and scroll down here. Let's go ahead and scroll down. Okay, so in this discussion here, there's a couple topics, major things that we're going to discuss, and these are some things that you'll need to have a good fundamental understanding of. Now, one thing that we can skip out of here, let's double check here and see, we should be able to calculate the gravitational force on an object in a gravitational field, be able to utilize Newton's law of gravitation, of universal law of gravitation, to determine the gravitational force of attraction between two objects. We should be able to do that. Determine the gravitational field due to an object. Definitely want to be able to do that. Differentiate between inertial mass and gravitational mass. Now, AP Physics 1 test, they do emphasize, or they do make a big deal about this. So we do want to discuss that. We're going to calculate gravitational potential energy next unit. We skip that. Explain weightlessness for an object in orbit. I think we already covered that with the elevator, so we don't need to worry about this too much. Describe key characteristics of geosynchronous and geostationary orbits. Definitely want to talk about that. If we have some time, we might discuss a little bit about Kepler's laws, but it's not tested on it. But this is a favorite subject of mine, so we'll go ahead and put a little heart here, and we'll see where we are on time, whether or not we'll do this or not. All right, so let's come on down here and let's start with universal gravitation. Now, before we start here, with all of these here, you should be kind of like thinking to yourself on a scale of 0 to 3, where 0 is I don't know, I want to cry. Okay, I want to cry. Or 3, I'm good, I can help other people. So think to yourself where you're at on some of these topics here. Okay, if you're kind of like close to 0, hopefully by the end of this discussion, we'll be more closer to the 3 here. All right. Put little eyes in there. Okay, let's go and take a look here. Now, this is universal gravitation. We'll let you go ahead and read this because I'm going to go ahead and do a quick discussion on what's here. So let me go ahead and let's go over here real quick. And little g. Okay, and okay, here we go. Let me put this over to here, and let me go ahead and let's see. There we go. All right. Supplemental gravitational force and force comparison. So let me go ahead and make a couple circles here, and we'll kind of get started here. Shapes here, and let's do a circle. So I'm going to make 2 circles here, kind of like about, let's see, like right here, and let's make one more. Let's say maybe make it a little bit bigger. Okay, doesn't really, yeah. Okay, here we go. And let me let's see. Let me hit pause real quick. Okay, sorry about that. So here we have 2 objects, and maybe we'll go ahead and call this here. See, hold on, still on. Let's go to right here, drawing. There we go. We'll go ahead and call this here mass 1, and I think I want black. And this over here will be mass 2. Okay, so here we have these 2 objects here, and they're because of Newton's law here, there's a force of attraction between these two. There's a force going this direction, and there's also equal force going in this direction, just opposite in magnitude. So these 2 forces are attracting each other here. Okay, and this is M1. This over here is M2. Now, a couple of things here. Here's the center, and we'll go ahead and call this radius 1 here. There's radius 1 here, and we will call this here radius 2. Okay, and in the middle here, we'll call this we'll call this d, distance between the 2. All right. So what Newton thought about when you have 2 objects is that there's a force of attraction. Okay. Attractive force. We'll say force is we'll say what is proportional to m1 times m2, and it's attractive. Okay, attractive. Gravity is an attractive force. Okay, attractive force. Okay. All right, attractive force. All right, and then Newton also discovered that it's also force is also proportional to 1 over the distance squared. So let me go ahead and write it like this first. Okay, distance, we'll say squared. Now, distance, what is the distance here? How do you actually get the distance? So the distance really is R1, okay, it's R1 plus this distance between the edge of the spheres here, we'll call that D, plus R2. So all of that is the actual distance from center to center. Okay. Now what we'll do is to make it easier for ourselves, we'll just go ahead and call it 1 over R, where R is the distance from the center here all the way to the center of the distance here. So you got to be careful about the distance. Make sure, whenever you're calculating a problem here, you may have to, calculate this distance here plus R1. Okay, but make sure when they're talking about the distance from center point to center point, because that's a source of error. Okay, and hold on, and this should be squared here. Squared, and this here should also be squared. So that's what Newton kind of said. Now, it wasn't until after he died, about 100 years later, a guy named Cavendish came along, and he actually did some experiments with the spring scales. And we'll actually do this lab, number 34, which is called a gravitational constant. So in order to make this into an equation here, a guy named Henry Cavendish did some experiments, and he came up, so he knew it was mass 1 times mass 2. He got that figured out, and he also realized that it was a distance squared. Okay, so what happened was there was a proportionality constant, and this is what we call big G. This is universal law of gravitation. Okay, and big G has a value, we'll say 6.67, and we'll say e to the minus 11. Okay, that's the value here, and it does have some units. Okay, what are the units of G here? Okay, so if I want to find out what the units are, let's take a look here. We know that this is newtons here. Okay, and this is big G. So this is mass times mass, which would be kilograms squared divided by, this is radius squared, so that's meters squared here. So if I solve for G, the units of G are going to be Newton meter squared over kilogram squared. So this will be the units for the universal constant here. So we'll say Newtons meter squared over kilogram squared. All right, so this is the universal constant, okay, universal gravitational constant, okay, and we'll have a whole lab dedicated just to this right here. All right, so there's a force of attraction that can be calculated by using this formula right here. Okay, if I know the two masses, their distance, I can calculate the force of attraction by this formula right here. Okay. All right. So let's go ahead and scroll down some more here. And now we don't want to get into too many laborious calculations here, but there is some things here that we want to be able to look at. I call it force comparisons. So what does that mean? Let's take a look here. So let's say the original force, okay, we'll call it FO is the original force. And let's go ahead and call it like this. Let's say it's big G here, and we'll say it's mass 1, this here will be mass 2, and we'll say the distance, we'll say r squared. So this is the original equation. It looks like this. Okay, now so we'll call this the original. Okay, this is original. Okay, there's original. Now let's suppose now we have a new situation. So we'll call it situation A. Suppose M1 is doubled. Okay, how will that affect the force? Okay, M1 is doubled. How can we get this new force that's in terms of the original force? Okay, how's that happen? Well, let's find out. So let's take a look here. So this will be the new force here. Here's F here. Okay, and G, nothing's happened to G, but M1 is doubled. So that means we have 2m1. That's what doubled means. And then m2 is not affected. All of this here divided by r squared. So using some algebra here, I'm going to move 2 out over here. So move 2 out here, and here we have g, here we have m1, we have m2 all over r squared. Okay, now take a look at this part right here. Now what's this part here? That's simply just FO. So we can substitute this FO into here, and we get 2 times the original force. So what that's saying is, if all I need to do is double M1, and I'll have 2 times the force of attraction. Okay, all right. So take a look at another situation here. Okay, let's say M1 and M2 are both doubled. Okay, these are both doubled. Okay, what's going to happen now? Okay, so both doubled. So the new force here, okay, we'll take our time here. This will be 2m1 here times 2m2, like so. All this here divided by r squared. Now we can factor out the 2, multiply and simplify, and I should get 4, right? G, here is m1, here is m2, all this here divided by r squared. So again, this part here is my FO, so we see the answer is 4 times the original force. That's if we were to double M1 and M2. Now, this is much more convenient than trying to do these computations with numbers and stuff, because I would just say just use the online calculator because it's very tedious. Okay, let's take 2 more examples. Take a look at C here. Now, suppose the radius r, yeah, it looks like a K. The radius r is, let's say, doubled. Okay, that means we're going to take these 2 objects and we're going to create some distance between them. So r is doubled. Okay, r is going to be doubled. Okay, so let's take a look and see what that effect is. Okay, let's take a look at that. All right, so here's the new situation here. Here's F here, and G is left alone. M1 is not involved. M2 is not involved, but R2 is, or R is doubled. So it's going to be 2R. Now you got to be careful here. You got to put in parentheses. It's squared, right? So this ends up being G. Here is my M1. Here is my M2 here, right? And this is going to be 4 times R squared. Okay, so now if I do some factoring here, or not factor, just rearranging, there's 1/4, and this part right here, right, is going to be my FO times FO. So by doubling the distance, I get 1/4 the force of the original force. Now, what does that mean? That's kind of like what's called an inverse square relationship. Okay, so if I was to take F here and I was to plot it against R, so it should be something kind of like this here. It's called inverse square law. Okay, so inverse square. Let me go ahead and kind of hit pause here real quick. Actually, let me make this this graph kind of sucks here. Let's get rid of this graph here. So inverse square graph. Let's kind of do a quick sketch of that. So here we go. Here's R here. Okay, so let's say that this here is 1, and let's say this is 1 here, and we'll make this 2 here. This is 3 here, and this will be 4 here. So if I have 1, so let's say so there's 2, so I'm doubling my distance here. So this has to come way down like this, is inverse square relationship. So if I double the distance, the force here gets cut in half, or gets 1/4. Okay, it's 1/4 inverse square. Okay, all right. Now, likewise, let's take a look at D here. Okay, suppose in this relationship here, I say R is halved. Okay, is halved. We're going to cut the distance in half. Okay, cut the distance in half. Let's see what happens. Okay, half. R is half. So what does that look like? It looks like 1/2 R, like so. 1/2 R. All right, so here's the new situation here. Here's my F here, right? And here's big G. Here's my M1. There's my M2. All this here divided by, we'll say here, 1/2. This will be R, and we're going to square it. Okay, so let's see what we get. Okay, so when you have here, we're going to have here, this is going to be big G here. Here's my M1. Here's my M2, right? This is going to be 1/4 R squared. Okay, now it looks kind of funky being in the denominator here. So we'll do some algebra here. We'll flip it. This now becomes 4 times G. And this is M1. Here's my M2. All this here, divided by, what do we have here? Divided by R squared, like so. Okay. All right. So this here is my FO. So we can see here, this is 4 times the original force. So if we cut the distance in half, it would be the opposite of this here. The force of attraction increases by 4. Okay, so that's called inverse square relationship, and this is kind of a good technique to just be aware of, or just be able to use. Okay. In fact, let's let you guys do this on Edpuzzle. Here's a question for you. Tell me, doing the same thing here, what happens if R is, let's say, doubled? So R is doubled. M1 and let's say M2 are doubled as well. Okay. What's the new force? What's F in terms of FO? So go ahead and pause here and go ahead and try this problem out. Okay.